Hello, everyone. So last but not least, so the few that are still here with us. So this is going to be, actually, I'm sorry, this is the last one. The last presentation is going to be packed full of a lot of things because this is my journey, my very long journey with the nCine, 14 years. Here you can see the logo is here as well. So let's start. What is the nCine first? Let's start with that. So it's a combination of my nickname and the word engine. And basically, it's a cross-platform 2D framework that you can use for games, for tools, prototypes. It's cross-platform because it works actually on PC, on Android, and the web as well. It's written in C++11, but it has optional Lua bindings if you want to script your games. It had from the start a strong emphasis on performance and optimization, and is released on GitHub with a very permissive MIT license. And for me, it has always been a learning opportunity, and I want that can be, I think it can be a learning opportunity for its users as well. So those are some screenshots from some of the projects that use the nCine in some way. We are going to see those more in details later. So why yet another custom engine, right? So for me, first and foremost, it was a way to handle my job frustration at the beginning. And today I still keep myself motivated by working a bit on it every day. As I said before, it was a learning opportunity to become a better programmer, to learn things, very low-level things about C++ that I wanted to know more about. And today I would like others to use it. I would be super proud if someone else would use it for to create tools or prototypes or games. And also because I think there is some innovation stagnation nowadays. Everyone is using Unreal and Unity, and we need more custom engines. There is also, you can see the representation, me presenting this presentation. You can find it online about custom engines and why we need them. This is sort of an overview about the lines of code in my project. Many of them are actually unit tests. That's how I think everything began for me, Amiga 500 in 1991. So I leave my age calculation as exercise to the reader. I started with the Amiga because, yeah, it had great games. So for me, of course, I was attracted by games, but they also had a lot of demos. So the demo scene was really vibrant, and for me, it represented a way to. I conceived it as a way to pursue beauty and wonder through like the mastery of the machine. So it's the search for beauty and the technical part, which still resonates with me a lot. And then after Amiga, I jumped on Unix systems, still on the Amiga. So actually NetBSD on 6800, then Linux PowerPC, still on the Amiga, and then nowadays Linux on PC. So everything started in 2011. So it was my second year of working for a small indie company in Italy, and I daydreamed about doing graphics, doing engine programming. That was my passion since quite the beginning. But all I was doing was GUI work for games. So that's when I decided to take destiny into my own hands, and actually 14 years ago, we're very close, I started with this project on Mercurial because, yeah, I'm old, so coming from CVS and SVN. And one thing that is maybe curious is that I deliberately neglected rendering because I wanted to see everything around the engine. So the render was super simple with fixed pipeline of NGL1. Yeah, that's my workstation at the time, a small Lenovo 11 inches, so small screen, big dreams, right? So I started with the tools that I still use nowadays, which are Arch Linux, Qt Creator, CMake, GCC, and Oxygen as well. Android support was something that I kind of added from the beginning, so that's why cross-platform is a very, very important thing since the beginning. Also performance. So things like Sprite Batcher, I had some experience with XNA, so I tried to replicate it. Texture atlases, which are useful, again, for optimization. Also, one interesting thing is that I didn't use STL, so I had my own containers. I had my own, as you can see down there, that's like a plotter based on histograms, all custom made for profiling. GPU block compressed texture for Android mainly, and you can see as well particles or a bitmap font that was used for text rendering. So in 2012, I moved to Cambridge to work for ARM. nCine was, of course, still ready in very early development, but already caught the attention of during my interview, and they were okay with me releasing the source code in the future. So I was doing a lot of developer relations. I was going around, traveling a lot, so maybe not so much developing, but it was a very interesting time at that moment. Also, sound was important. It was part of the engine, right? It's something that you use in your games. It's not all about rendering. So I added support for an OpenAL-based sound system. Then more support for Android, then GLFW as an alternative to SDL1. So this is something we're going to talk about later. So the support of multiple system backends for window handling for inputs. And then also threading API, which uses both POSIX and the WinAPI primitives. So like it's a common API for threading and synchronization, which was a very low level thing that I wanted to learn more about. In 2013, Android was really, maybe nowadays, I don't know if you are familiar with Ouya or the Google ADT1 actually is a developer-only device for Android TV by Google, which I was also gifted when I went to Unite. And so for me, it was like, yeah, maybe Android can be seen as a console. All those set-top boxes, maybe they are consoles. So if I support that, I kind of be a console programmer, right? So they have their own SDK and things like that. So for me, it was a way to, like supporting Android well was a way to support consoles in a way. So 2013, I've seen not a lot of progress, and as you can see from the arrow there. But I did some work which I think still it's important, like the high precision monotonic clock, which we will see in a moment in more detail, or MIP mapping, which is still a thing for performances, and also to reduce the bandwidth on mobile devices, which is important. And again, the last three bullet points are about the system backends that I was commenting before. So the API seems to be quite generic enough to have multiple system backends, the 4 that you can see there. And then a user also made support for Universal Windows Platform for Switch. So it seems like the API is good enough. So monotonic clocks here. So the peel, that's a technical peel. You will see more later. So as you can see here, yeah, probably it's not. So as you can see here, we have three. That's the interesting thing. I think that we have 3 different implementations. It's not just POSIX and WinAPI. Also, the Mac kernel, which is the macOS kernel, has a different API for clocks. And per each platform, you have a fallback as well, because maybe you have performance counter, high precision, maybe you don't have them. So monotonic clocks, because they are a counter that always, they count from the system boot and they can only increase. So even if you change the system time, your time zone, you change the clock of the system, those are like stable and they will always increase. And also they are high precision. So that's important if you want to do like time profiling or see how much time has passed since frame. Those are the ones that you want to use. Gamepad support are another thing that this is like connect to the Android as a console, right? So gamepads. If you want to have a console-like experience, you need to support gamepads. And actually on Android, they are a bit painful, because if you want to support everything, you need to go to the Java API, which means JNI if you want to do things from C++. in the end, you can see I've added the string class, or I mean, more things to the library of my containers. Also, static array that has like the capacity as a template argument, so it's fixed and doesn't allocate on the heap. In 2015, I moved to Oxford. So ARM was nice, but maybe, as I said before, not enough developing. So I went to Natural Motion in Oxford, and I was an Android technology programmer. So I was working on the engine. They had a custom engine for Clumsy Ninja, Dawn of Titans. It was the same engine. And actually, I shown some code from the nCine when they said, show us some C++ code that you have written. And I pointed them to the nCine, and they were pretty happy, actually. And still, this company was like ARM. They said, yeah, if you want to release it in the future, we don't have any issue. OpenGL 2 renderer. So as I said, I started with OpenGL 1, so fixed pipeline. Here I moved, this year I moved to a new renderer. Again, more thing about containers and stuff. So the OpenGL 2 renderer, basically, yeah, I had to add shaders, shader programs, and vector and matrices, because now you have to pass them to the shader attributes and uniform. And I needed to add a new hashmap container, because those are like based on names. So you have in GLSL source code the name of the attributes and the uniforms. So actually, I use those as keys. And you can see here a render command that I use the material and the geometry class to do some binding, and then issue a draw call. In 2016, I started to go a bit more public with a GitHub organization. So even if I didn't release the code yet, but I started to create a Discord server, distribute the library as a binary on Google Drive. And then Fine, which is here, is him, Antonio. So we jumped on board. There was the first one with NC Rogue that you can see here. It's an RPG. It was an RPG prototype with an editor included, which was going to be released for Android. And here is also the year of NC Pong, which is the first official, I would say, NC project, which you can see here. The interesting, that's just a Pong, right? But what is nice is that if you go on the GitHub source code, you can see that it has both a C++ and the Lua version, so scripted version. In 2017, I moved to Stockholm. So rendering for Frostbite was my dream, right? At least it seems like. Again, I used the nCine here to reply to an interview question. I didn't know something about the STL. I think it was about string allocation or something. And I said, I don't really know, but that's what I do in my framework. And they were happy enough. The problem here is that I couldn't release the source code. Yeah, it's super restrictive. You can't do anything. So I kept sharing binary builds to friends. I worked on many. Well, actually, I worked on the engine, but I was credited in many games, so this was good for my career, at least. I started to publish some articles on my blog about all the developer technical things behind the engine, and I added more things about like a culling of sprites, which is an optimization, or SDL2 has a way to parse button and access mapping. And I kind of ported this thing to other backends, so you can have this function on Android as well. Here, 2018 has many technical builds, because I've added plenty of things. So I catched up with times with C++ 11, a new renderer. I worked a bit on SIMD intrinsics, but at the end, I left the work undone, because the compiler seemed to do things pretty good. This is a snippet from the Pong in Lua. Oh, let's go to another technical piece. So atomic counters, they use the intrinsics support from the compiler, and they're a way to do some integer mostly modification in an atomic way. So on an integer, they do some operations in an atomic way, and they enable interesting things. For example, lock-free data structure that are used later in when we will see the job system. So in this snippet of code, you can see that top is an atomic, the value is loaded in T, then there is something is happening, but the thing is that not only this thread, there are multiple threads executing probably, possibly the same part of the code, but then we want to know if this actually happens. So if top has been changed, so this is a queue. So if the top of the queue has been changed by another thread, then we don't want to mess with the old value that we want. But if nothing has happened, and we say in the compared exchange, we say, okay, I want to write my new value, which is t plus 1. If t is the old value, I mean, the old value that I kind of cached there, it's still the value of top, then it's okay. No thread has messed around. So I can continue. Otherwise, I abort. In 2018, I've also added a couple of things that I felt that were interesting about C++11, null pointer, override, equal delete, so all these kind of things, nice keyword, right? But mostly the most important things were the support of move semantics for my containers and also my own smart pointer. So I have a unique and shared pointer made from scratch. And I changed all the row pointers in the code for smart pointers. The new renderer, right? Things that I think were important with this jump on a new OpenGL API version are the debug extension, which offer nice things. Vertex array objects, it's something that you have to deal about, or you have a black screen otherwise, and it's a way to switch between vertex formats. UBO are important to send data to the shaders. And I started to handle memory in a different way, so with different kind of mapping. And I try to have one VBO, so all the verses together in one buffer, all the indices together in one buffer, and so on. And down you can see part of the code from my batcher of render commands that, so it receives a sorted queue based on this sort key. And then if some conditions are true, then it has to split, right? For example, if the sort key is different, actually in the lower part of this sort key, there are information about the material, so the texture, the shader. So it means, oops, I cannot batch all of those together because I have to change things in the OpenGL state machine. So I have to split here. Here is that's the sprite, my sprite shader. Things to notice here is just that I don't pass texture coordinates, don't pass vertices here. I just kind of generate them. I just say I want 4 vertices. Then OpenGL gives me the GL vertex ID built-in variable. And with that, I can generate position and text coords, and then of a square. Then if I want a rectangle, I can use, I will use the uniforms from the UBO. So the text rect and sprite size, they can alter these -1, +1 text coordinates or vertices and create a rectangles. Those are some render doc screenshots. You can see mesh sprites. You can see the generate vertices, which are useful when you have a triangle list. So you want to jump from one sprite to the other, which is in a different position, and you can just issue triangles, right? But you don't want a triangle to move from a position to the other. So what you can do is repeat the same vertex, which is called a general vertex, which is something which is supported. And then you can see that there is a line and you can move without drawing any triangle. You can see down there more information about the instances in the UPO, or the way all those vertices are batched together again. And in the last one, down on the right, you can see some information from the debug extension. So that's very, very useful. In 2018 was the birth of I had containers based on templates and everything, but this is the birth of something which is like more of a project, even if you really can't use, at least at the moment, outside the nCine, but now it's more of a sub-project. So I use Google Test for unit testing, which is super important because actually you want this kind of library to be correct because everything it's based on top of that. And you also want to see if performances are good enough because yeah, you're not using STL mostly because you want to learn things, right? You want to do everything from scratch. But after some years, you also want it to be at least good enough in your little framework that wants to publicize that it has strong emphasis on performance, right? Actually, with Google Benchmark library, it seemed like performance were okay, faster than STL, which is very generic, right? So Qt Creator on the right showing support for Google Test. And here, this is gcover. So coverage is very important for unit tests. So you don't only want, you want to write your unit test, supporting what you do, all the operations, right, of your library, of your hash map, insert, remove, whatever, but you are not really sure that your test actually stress that code. So that the unit test call those lines of code or your templated list, for example. So that's when you want something like this tool and the support of the compiler to actually see graphically, visually, if you are really, like your unit test is really calling those lines or not. So the template library, so it has, as I said, hash maps, pointers, whatever, strings, parsets, a lot of things, unit tests, benchmarks, whatever, custom allocators as well, we will see later. So some of the techniques that I used here of generic programming are, for example, type traits, tag dispatching, nCine. For example, here you see that you can do everything from scratch. There is a base point. For example, this is trivially constructible that I use for type traits. Here you need to use compiler intrinsics. You cannot do it in any other way. STL is doing the same. And actually, this is used to, based on the type, so the struct array is destructing an array if the array is made of types that are objects that are not trivially constructible and they need to be destructed. Otherwise, if it's an array on int, it's not trying to call the destructor. So yeah, you can see on the top, destruct array. So you destruct the object and then you free the memory of the array. So those are two different things. And down you can see another interesting things that move in C++ 11 is just a cast actually between values. So this is the same. I've implemented it from scratch, but STL is doing the same. And here is tag dispatching in action. So you can see those are two different versions of distance, the distance function. So STL is doing something more or less similar. So you have two iterators. So if the iterator is a random access iterator, then you can do something like a subtraction there, because probably they are pointers in an array. So you can probably subtract those two pointers and have a value and see the distance between those two iterators. But maybe your iterators are from a list, so they're only going maybe forward. So if you want to calculate the distance, you have to use the other code, which is actually going forward, is counting how many times it can increment the iterator. So the fast path is the top one, and the other one is if you don't have a random access iterator, you have to use the other one. But the important thing here is tag dispatching, and with type traits, it's resolved at compile time. In 2018, it was also the year of DRM GUI, which is super important. So I removed all my plotters and stuff, right? So with DRM GUI, I can have a debug overlay interface. I started supporting Tracy when Tracy was basically completely unknown, I think in 2018. And I already seen that it was a great, great program. So I started integrating it. So that's another project that I wrote with an artist, which was supporting with the project. I mean, doing things as an artist. I can provide the editor, but I'm not artist. I cannot do beautiful things, right? So the thing that we were saying before. And also, I implemented this optimization, which the STL is also doing. So this is a way of, if you have a string object, which is going probably to be, well, actually, it's going to be loaded one cache line at a time. So when you bring your string object in the cache from memory, if your string object is occupying less bytes, you're probably wasting some prefetching of the CPU. So what you can do, what STL is doing as well, is let's see where our cache line boundary is, and let's put some characters. So if your string is small enough, so there is here, for example, is 16, but can be different, then you don't need any heap allocation. And then if you need more, so if you change the capacity, then yeah, of course, you're going to copy, to allocate memory and copy your small buffer size. In 2019, that's when I went to Granada in Spain. So I left Sweden, I left EA, I left working. I quit my job, actually. I couldn't work anymore. So now I have more time, right? So I can release the nCine on GitHub. That's what I've done, of course. I did some experiments with ECS, which I need to get back to. Support for the web. And the integration with, for example, here, RenderDoc. So here, that's real integration with the RenderDoc API. It's not just that, yeah, you can capture RenderDoc. Yeah, you can capture everything with RenderDoc, but you can have the debug overlay interface, and you have capture from inside your the interface. Actually, that's silly. So the important thing here to have the RenderDoc API is that if I want to capture something programmatically, because I'm doing something strange in one frame and I want to know more what happens at that precise point, then in my code, I can put a call to the RenderDoc API and say, I want to capture really this frame. And then a new hash map, but we're going to see it in detail. So 2019, I had more time, so many more projects, right? And also collaboration with a guy, we will see also in more detail, which led to actually, I think, making the engine a solid sprite blitter. So it was working correctly, I think, because it was really stress testing everything. So spacing bounders, everyone has a spacing bounders, right? So this has some data-oriented design principles from my Frostbite technical assignment interview. This is prototype that I made when I was in Spain. I wanted to sell a game, whatever, and then finding I did for the first time was nice. And you can see it here. Actually, with utility I got completely stuck. I'm sorry, but it was like, yeah, it's nice, great. I started to watch a lot of videos, but then I was like, it's not working. I need more time. And then I just left it, but it's still there. Maybe I will get it back to it. This is another strange tool. So this is C++ tool. I started with a Python script, but then it was all C++ tool, calling Git and CMake, working on macOS, on Windows, everywhere. And that was a way to make it easier to either download the artifacts from the CI or compile dependencies and things, because in Frostbite, we had something similar. So a script to set up the project, download stuff. So you can find it still online. It's working pretty fine. Then I started to study a bit more using that book, study a bit more about path tracing. So this is an interface for my poor man ray tracing library. It's brute force, super stupid and simple, just CPU, but it's multi-threading. It's working more or less. I mean, this is the classic kernel box with not noisy, but to achieve this was like a lot of hours on a big PC. So it needs more work, definitely. Then Jugilus, right? The guy that was doing this tool, he wrote me one day a lot of features because he was doing this map editor, or kind of similar to Tile, but it had some logic in it. So it had also some runtimes to actually load those maps inside some engines. So I wanted to support the nCine as well, so I put the framework under a lot of stress, and it seems like it was the fastest of those of the bunch. And actually, I'm super grateful that he had the patience to work with this small framework as well. So those are some of his tests. Then let's call about leapfrog probing. Probably you know about separate chaining as a collision resolution strategy for hash maps. So key 1 and key 3, they both got hash to bucket 0 in your array, in your hash map. And a way to fix this thing is to just have actually a chain. So when you want to retrieve the key, you say, is the first one? No, because when I hash it again, it's not that one. So let's follow the chain. Thing is that, of course, being a list, your cache locality is not good. Your space locality is not good. So cache is going to be trashed a lot. You're jumping around in memory. And one other thing that you can do is open addressing. So you store everything inside the array. Problem here being that you probably need to rehash when you're going close to a load factor of 1, which is 100% utilization, while if you have a list, you can potentially go around forever. And the leapfrog probing is a way of kind of finding your next position if you have a collision and that spot in the array is taken already, and it uses more data, so it has some helper data, those deltas. So when you find a new spot, you kind of write where you are. So the next time you don't have to say, let's see where is the next key, right? You can jump directly to that. There is an article. So those are all online, the slides, so you can click. There are a lot of slides that you can, a lot of links that you can click. In 2020, file system class, right? So C++ 11, yes, but I want to do everything from scratch. So POSIX and Win API implementation for file systems, or loading, creating directories, browsing directories, deleting files and everything. Support for UTF-8, so you can see the Iliad there. In my font up test, I started to think about what do I need to do an editor? What I need more flexibility. So, for example, if I try to load a texture, the file is not there, I shouldn't assert. Maybe I should just continue, because in the editor you probably need to load a different texture, do things. For example, you want to create 10 sprites and then assign textures. This flexibility was needed, actually, if I wanted an editor, which is something that I want to do in the future, right? Custom memory allocators, which I will talk about later. And I didn't get an Epic Mega Grant, even if I tried to, but actually I got the Iculus Micro Grant. So Iculus is, the creator of SDL, a super known developer of doing a lot of porting to Linux from ID Software games. It's like an eminence. 2020 was also the year of Spooky Go. So I tried to create this tool for artists. So this is for procedural animation of sprites. Yeah, didn't gain any traction. So I kind of converted it as an open source tool that you can download. You can still donate if you want. This is another tool, another project from Fine, which is up there. I tried to demonstrate what nCine could do. So I created this game using Box2D. So I did the integration. I'm GUI for the editor. You can see an editor there. And I worked on my Steam Deck as well. This is the test for the allocators, showing what happens in memory. That's a memory map created with a custom MGUI widget to do the graphics. And you will see later about allocators. Continuous integration was super, super important as well, because we have all these matrix of platforms and compilers and build flavors. So this cannot be tested by hand at every commit. It's impossible. So I have a way to test it with GitHub Action, and the GitHub Action script will also, it's also, I think, useful, push on every project will push in a different repository with branch per platform, so you can download artifacts. So custom allocators, it's not super, it's basic allocators. I wouldn't use those in production yet. So you have a classic linear allocation, which probably what you would use in your frame, right? So you only allocate and then you kind of free everything together. It's something that is super fast, right? For allocation, for a frame might be used. A stack, it has a stack of allocation. Pool if you have objects which have the same size, and then the classic free list that can allocate in the allocate, can also kind of defragment, coalesce the adjacent free blocks, but it has like something that you have to trigger. And also I like all those libraries have, they support custom library, custom allocator. So you can say, no, use my custom allocator. So that's what I'm doing. Not for Vulkan because I don't have yet Vulkan support, but I will in the future. Down here, you can see some tricks because this allocation manager is static and you want it to be the first one to be created. So you need some pragma tricks or GCC attributes to actually say, no, it has to be the first one. Here's something that you maybe won't see a lot. So, but with custom allocator, that's the case. So new and delete operators kind of overridden if you want. So everything goes through your allocator if you want. So there is standard new, array new, standard delete, array delete. Also, something that maybe you won't see a lot is, well, placement new. So there is this new that says, no, I want it here because I have a buffer. I created a buffer. I have my memory. I just want you to put my object there, which means don't allocate, just construct where I tell you, which means as there is no delete placement that you need, and this is one of the very rare cases, you need to actually call directly explicitly the destructor because you just want to destruct, not to delete the memory. In 2021, I started working from home because I was kind of bored to be poor, right? So I started with the MPG rendering again, and they were just fine. Yeah, continue with your things, with your open source thing is no problem. And I was working for on Starfield and on different projects and other things, but got a Raspberry. Everything was working there as well. Again, thinking about an editor, so you don't want Lua errors to make the whole thing crash, right? And this is another project. So yeah, creating a custom editor is a lot of work, right? But maybe if I show how you can load maps from tiled, maybe you can use that as an editor, and it's still better than nothing, right? I had to add a custom feature just for this project. So in tiled, there is a support for chroma key. Yeah, so here fuchsia or magenta is the color to be treated as transparent. So I needed that. I didn't have this when loading text. That's just a small anecdote. 2021, well, CMake scripts. I always had a lot of CMake scripts. So why all those thousands of lines? They don't do only the compilation. They download source code of some dependencies, because I have another set of CMake scripts to actually build the binary dependencies. There is a lot of CMake, yeah. Also, they need to create archives or installers for macOS bundles, the APK on Android. There is a lot of things actually that I think I couldn't do it without all this amount of scripting. Also, they need to support my projects, right? So there is a different directory for projects. So if you have a project like a template project, I have an example template project, then you just need to say, this is where my framework is. And then you have a very small amount of, you can see here, like you have 20 lines. Like, don't let it beyond this line, then you have 20 lines, and just looking for where is the nCine, and then we will kind of bootstrap using 1,000 lines from here, right? So you just have to set those custom variables if you want to do something. You also have callbacks, so you can have some functions. If you have to do really custom things on CMake, you have some callbacks supported by this system. 2022 was all about, I want to do advanced graphics. I need split screen and post-processing and stuff. And also, yeah, there's another user that actually rewritten this project. So this is Jackrabbit, 1998 game from Epic Games, which was called Epic Mega Games at the time. And he actually has a C# implementation of the game, and he wanted to go native. I don't know why actually he chose the nCine. Actually, he did like a fork. It's super custom, but it's still the nCine. So with him, I can talk about the architecture actually because he knows a lot. So multiple viewports. So you can see here multiple different scenes, different point of view. You can have different seesaw, rectangle, and stuff. OpenGL, and here custom shader. So this is normal mapping and Bloom. So Bloom made with Blur. And let's see here. So with viewports, yeah, you can do split screen, but you can also do things right for Blur ping pong technique. So viewports is a way to put together an input, which is a scene node, which can be your whole scene. So it's like a tree. Then you have shader, and then you have an output as a texture. So what I'm doing there, the table is maybe more clear if you can read it. So I render the whole scene in a texture, the pink texture. Then I have another viewport that has sprite covering the whole screen with this pink texture, but then I have a blur shader, and then I write on the Pong texture. And I do this a couple of times. So the next time you kind of render a Pong sprite, which has like a Pong texture, and then write on the ping one. And in this way, you can do a multipass thing with this system. And for example, here you can see I have this fallback for every viewport. Do something. So in my example from the Bloom, I do something like that. So if is the ping viewport, then I change some uniforms to change the direction of the separable blur kernel. And custom shader, you have shader that you can reuse. So this is not the GL shader class. So this is a layer on top. This is what the users see. It's a public API. So the shader is can be reused by multiple nodes through the shader state that kind of link everything together, and also has the concept of uniforms. So that's another thing that actually the guy from Jackrabbit asked was cache for binary shaders, because for Xbox or a universal Windows platform, it uses Angle, which means DirectX, OpenGL on top of DirectX. So it has to translate shaders. It's super slow. So with caching was faster. Also introduce another feature about with introspection. Let's see how much I can batch in those shaders, because there are some devices, or mobile probably, which expose less than the minimum, which is 64 kilobytes in your view. I don't know why. So binary shader case. So you can see here a call from the file system class. So cache path. So cache path results actually to those 3 different directories based on the operating system. Then in the generic system cache directory, there is this nCine shader cache, and then there are those binary. There is a text actually with a list, and then there are those files, and I have to put together some numbers or some hashes to see if actually I can satisfy this load request. So it's not only actually the shader name, which means I want this shader. I want this binary format, which is something internal of OpenGL, but there is also another variable that we need to take into account, which is if I update the driver, then potentially the binary can be different. So I also hash the GL render and GL version strings, which kind of encode this thing. And actually, I can also prune shaders that are from old version. So some GitHub recognition, 1000 star. Yeah, the presentation about the custom engines. I started to write the wiki, getting started and guide. I wanted more users, right? And started developing this multi-threaded job system that we will see in a moment. This is from, I use that as a reference, those articles. So they use a thread pool. So you have 1 thread per logic core, spawn at the beginning. We don't create and destroy all the time because it's costly. Then we have work stealing queue. That's a way. So you only, each thread has a queue, and it can only enqueue in its own queue, so it cannot touch other queues. What you can do, what a thread can do, is actually steal from another thread queue, and this is a way actually to do an automatic load balancing. And this use lock-free, so we have seen from before, yeah, atomics. It has also a concept of parent-children, so you can see there, every job might have a parent. This is a way to have multiple children with the same parent, and you say, just run everything, and you say, I wait on the parent, and then it means that it needs to satisfy all the children and needs to finish. There is also another concept of continuations, which are jobs that will run immediately as a job finish, and they're listed there. And then the parallel for is a way to have automatically a function run on a split of an array. So everything is kind of automatic. You give the date, the data, how big it is, the function, the split is going to be automatic. And this needs, this works with the job that enqueue more jobs. They create sub-jobs. Also, you can see that they have a condition variable to wait for the queue. So if the queue is empty, there is nothing to be done in the thread function. Otherwise, they kind of be signaled. They're signaled and they start doing things. Thread local, so another C++11 thing you can see here, a keyword, to have like a thread ID different, like a different thread ID per thread. And what happens when job finish, the unfinished jobs atomic gets decremented, and then we have the parent also gets signaled, and then we have continuations, like as we said before. Here, there's the way to handle job ID as numbers or encoded data, like an handle, so that the user doesn't have a pointer directly it's still a pointer, but it doesn't appear as a pointer, right? And then here is a tracy showing that actually, yeah, I enqueue everything on the main thread. This is on top, but then the work stealing gets like running really fast, and they are all kind of distributed. So this is they are all filled with work to do. In 2025, yeah, I got hit by layoffs, like many others this year. So I had more time, right? Yes, so I tried something different. I wanted to try doing the global game jam. It was my first game jam. I even said maybe I can do some sponsoring for the event. I tried advertisement with small budget. It didn't work. ChatGPT actually told me, because I use it for brainstorming. Yeah, why don't you contact Valve, right? So because Vulkan, no, I don't use Vulkan, but maybe in the future we're going to use Vulkan and the Steam Deck, right? The low level, yeah. Okay, so I just contacted one in Valve. Of course, no reply. I updated the README. That's important. Put always screenshots on your README. And I applied for conferences. This is one of those. And IntroSort. We're going to see IntroSort. That's the bug that I gave as for there. When I was at the Global Game Jam, I was a sponsor. This is the game. It's still in development. So this is not the game from the 2 days. I'm still kind of, I want to polish it. I want to publish it open source, and as a way to get the nCine better, but also as a showcase for users. So you can see there, RTX off, RTX on, right? So this is a refraction shader, so custom shaders. Introspective source of, what is that? So actually, Death Killer, the guy from Jazz 2, said, yeah, I switched to IntroSort because I got a crash. So I was using Quicksort for my render commands, but it had a super big scene and it was crashing because sometimes Quicksort do something like that. So it goes super deep and you kind of crash your stack, and or it gets super slower, can do one of the things, and it explodes. So actually introspective source, something that the STL uses, Python I think uses, and many different libraries. It's a way to do sorting in an hybrid way. So you have few elements. Insertion sort actually is the beginning. You don't have it is the fastest. You don't need to divide things, right? Otherwise, more than 16, in my case, 16 objects, then Quicksort is fast, and ipsort if you don't want to go too deep with the stack. So that's how you do. You calculate the depth based on the number of objects, and you say more or less that's my maximum. And what you do actually is, so the else part, the big part, is actually what I had for the Quicksort. So it's calling IntroSort on the partitions of the Quicksort, which means I'm partitioning like quicksort, then one of those partitions, as I'm going down, is either smaller than 16 elements, and only on that partition, I use insertion sort, and then I join back with a quicksort, or I got too deep, and then again, on that partition of the array only, I use heap sort. What about AI? Yeah, as I said, it helped me brainstorm the idea, right? So contact valve, for example. Yes, also idea about games. Yeah, was nice. Something about intro sort, quick sort with a unit test also was kind of, actually I got surprised. It was quite good. Helped me proofread this presentation. I hope we got it right. Then there are some statistics that you will see later, and it helped me with throw like a prototype, let's say scripts. And I want this. I just want this this graph thing, and then I don't want to be an expert about that. Just create me that. So for that, I think AI is good. Then slide dev. So this is a web-based presentation system. It helped me with things that I didn't know about web, right? And then something about the refraction shader, the setup mostly. So those are the statistics. Thank you, ChatGPT. Yes, as you can see there, I'm really a vampire. I don't work. There is no morning. There is only night. So can we call this framework a sunk cost fallacy? Because yeah, you put so many years, so many time, right? You can't stop. It has to be your work, your mission for your life, right? I don't know. Sometimes I feel like that's the case, but not all the time, because yeah, I put a lot of time, but I think I've learned so much, and actually I enjoyed as well my journey. That I'm okay with that. Yeah, maybe will never become my full-time job. That's okay. Actually, what I would like to see is more user using it. Future work, yeah, infinite list of things. Yeah, I want to do the job system that I to finalize, support Vulkan metal and everything with graphics layer thing. Go back to the path tracer, do things with the network, the neural networks, and the innate evolution things, right? Maybe an editor, yeah. Since forever, I want to do an editor, fully fledged editor like Unity. We will see. So yeah, download it, try to tinker with it, and if you have some questions, write me emails. I really want it to become a learned opportunity. Here you have a list of all the things that we talked about, the technical point of view. Well, that's it. Questions, or you're all asleep? Mike is coming.
Hello.
Yeah.
Thank you for your talk. There was quite a lot of work you put in there, so really good. I'm actually interested into, you worked with a lot of companies, like big ones, and then you kind of, I felt you were not satisfied with it, right? But nCine was the thing that was keeping you alive, right? So can you talk a little bit about like what are you finding in nCine that all those dream jobs like Frostbite engine and stuff like that didn't give you?
That's a fantastic question, actually. So I think the only time in my career where I kind of felt the connection with the project was in Oxford, because we were like 10, 12 people doing the engine. Everything was coming at us. So it's just us. And you can do everything, actually. And I was doing at that time when Vulkan came out, I said, I want to do some graphics. Yeah, okay, do the conversion from OpenGL to Vulkan. And I kind of studied the documentation, the specs. There were only specs for 6 months. Then kind of Zynga happened and they closed everything. But it was really a time, and I think it's reflected in the commit data, when maybe I had a drop. It was the only time in my life where I kind of felt part of something. Then after that, never again. Frostbite, yeah, it's great. It's millions of code, and you can just maybe touch a very, very small part, and you are just a little cog in a big machine, and you can be replaced by that. Actually, not everyone. I mean, there were people there that were really kind of guiding the things, affecting. You could see that, yeah, there is his hand right there. Yeah, but those are people that yeah, they've studied a lot more than me, and they've been there for years and years. And actually, in Sweden, unfortunately, I didn't have this. I don't think I would have lasted more than the 2 years that I've lasted. So, and after that, after Sweden, actually, I got in a strange point where I didn't have any more interest in work. I actually joined my last work because, yeah, as I said, I was fed of being poor. But if it was for me, I was continuing with my things forever. Actually, I last kind of 2 years without a job, and I was super happy, super productive, which is actually what I'm doing now. And I don't know what's coming next. I would like this to become my kind of job in a way, but it's super hard. Otherwise, yeah, I will have to go back to work. We will see.
I would just want to say something. At the beginning of the presentation, you said you are not an artist and that you cannot make beautiful things. But I do believe what you showed us today is something beautiful, even though it's not visible to the eye. Right. 1. 2. What about Vulkan?
Oh, thank you very much for your comment. Yeah, it's true that some people might find beauty in that. It's just a small niche of very well crazy people. But yeah, I was thinking about beauty in a more traditional philosophical way of like beauty that you can feel with your eyes. So that's the connection with the demo scene. So you have beautiful code that only a very small niche of crazy people will say, oh, that's fantastic. And then you have the part where you actually see the beauty on your screen. So that's something nice I would like to do. And as you said, Vulkan, it's something important that I wanted to make it in the end, because there is another thing. So if I do all the things that I like here, say, the editor is going to take a lot of job, which is going to be satisfying, I think, for me, but I will lose my connection with graphics, with, I will kind of forget things. So that's another thing. Inserting the Vulkan in the nCine will be something to put in my curriculum as well. Yeah, I've done low-level stuff. I have a API layer that are abstraction interface for graphic API. It's something that I can use in my job as well. So that's something I have to keep in mind for the future.